Welcome to EDU World Space.
So we're told that the magnitude of the periodic force that's applied to this spring is equal to Pm times sine of the angular frequency times time. So now, because it's sine wave, because this is terms of a sine wave, when it's so for part A, when it's in phase, this means the natural angular frequency omega n has to be equal to 2 pi, because the frequency of a sine wave is 2 pi. If the collar is in phase, it has to be the natural frequency will have to be equal to 2 pi. So now we can use the equation that the natural angular frequency is equal to square root of k divided by m. Rearrange this, so if we square both sides, we'll get omega n squared equal to k over m. And we want to work out k, so if we times by m, we get that k is equal to omega n squared times m. So now we know for when it's in phase, omega n has to be equal to 2 pi. So we have 2 pi all squared times the mass, which we're told is 4 kilograms. And so we do this and we get 160 newtons per meter. And now for part B, it's out of phase. So for when it's out of phase, it's gonna, the angular frequency will have to be equal to, the natural angular frequency will have to be equal to pi, just pi, because to keep it out of phase all of the time, so that the force never affects the motion, it will have to be equal to just pi. So if we then do this, the same thing, so we have k equal to our spring constant k equal to omega n squared times m. And we do this, so now we have just pi squared times the mass, which is 4. We get our answer of 40 newtons per meter.